Class 7 Maths Chapter 14 Symmetry Animated Math Introduction. Symmetry is an important geometrical concept commonly exhibited in nature and is used almost in every field of activity. Artists, professionals, designers of clothing or jewelry, car manufacturers, architects and many others make use of the idea of symmetry. The beehives, the flowers, the tree leaves, religious symbols, rugs and handkerchiefs, everywhere you find symmetrical designs. We have already had a feel of line symmetry in our previous class. A figure has a line symmetry if there is a line about which the figure may be folded so that the two parts of the figure will coincide. Let us recall these ideas using some activities. Compose a picture album showing symmetry. Create some colorful ink pot patterns. Make some symmetrical paper cut designs. Enjoy identifying lines, also called axes, of symmetry in the designs you collect. Let us now strengthen our ideas on symmetry further. Study the following figures in which the lines of symmetry are marked with dotted lines. We feel line symmetry in all the cases. Lines of symmetry for regular polygons. We know that a polygon is a closed figure made of several line segments. The polygon made up of the least number of line segments is the triangle. A polygon is said to be regular if all its sides are of equal length and all its angles are of equal measure. Thus, an equilateral triangle is a regular polygon of 3 sides. An equilateral triangle is regular because each of its sides has same length and each of its angles measure 60 degrees. A square is also regular because all its sides are of equal length and each of its angles is a right angle, that is 90 degrees. Its diagonals are seen to be perpendicular bisectors of one another. If a pentagon is regular, naturally its sides should have equal length. You will later on learn that the measure of each of its angles is 108 degrees. A regular hexagon has all its sides equal and each of its angles measures 120 degrees. You will learn more of these figures later. The regular polygons are symmetrical figures and hence their lines of symmetry are quite interesting. Each regular polygon has as many lines of symmetry as it has sides. We can say they have multiple lines of symmetry. Perhaps we can investigate this by paper folding. The concept of line symmetry is closely related to mirror reflection. A shape has line symmetry when one half of it is the mirror image of the other half. A mirror line thus helps to visualize a line of symmetry. Is the dotted line a mirror line? No. Is the dotted line a mirror line? Yes. While dealing with mirror reflection, care is needed to note down the left-right changes in the orientation, as seen in the figure here. The shape is same, but the other way round. Let us play a punching game. Fold a sheet into 2 halves. Punch a hole, 2 holes above the symmetric fold. The fold is a line or axis of symmetry. Study about punches at different locations on the folded paper and the corresponding lines of symmetry. Rotational symmetry. We see many things around us which rotate either in clockwise or anti-clockwise direction. For example, fan, hands of a clock, windmill, wheels of a bus, etc. When an object rotates, its shape and size do not change. The rotation turns an object about a fixed point. This fixed point is the center of rotation. The angle of turning during rotation is called the angle of rotation. A full turn, means a rotation of 360 degrees. What is the degree measure of the angle of rotation for a half turn? A half turn means rotation by 180 degrees. A quarter turn is rotation by 90 degrees. When it is 12 o'clock, the hands of a clock are together. Have you ever made a paper windmill? The paper windmill in the picture looks symmetrical, but you do not find any line of symmetry. No folding can help you to have coincident halves. However, if you rotate it by 90 degrees about the fixed point, the windmill will look exactly the same. We say the windmill has a rotational symmetry. In a full turn, there are precisely 4 positions on rotation through the angles 90 degrees, 180 degrees, 270 degrees and 360 degrees, when the windmill looks exactly the same. Because of this, we say it has a rotational symmetry of order 4. Here is one more example for rotational symmetry. Consider a square with P as one of its corners. Let us perform quarter turns about the center of the square marked. 1 is the initial position. Rotation by 90 degrees about the center leads to 2. Note the position of P now. Rotate again through 90 degrees and you get 3. In this way, when you complete 4 quarter turns, the square reaches its original position. It now looks the same as 1. This can be seen with the help of the positions taken by P. Thus, a square has a rotational symmetry of order 4 about its center. Observe that in this case, the center of rotation is the center of the square. The angle of rotation is 90 degrees. The direction of rotation is clockwise. The order of rotational symmetry is 4. Every object has a rotational symmetry of order 1, as it occupies same position after a rotation of 360 degrees, that is, one complete revolution. Such cases have no interest for us. You have many shapes around you which possess rotational symmetry. For example, when you slice certain fruits, the cross sections are shapes with rotational symmetry. Then there are many road signs that exhibit rotational symmetry. Think of some more examples for rotational symmetry. Discuss in each case 1. The center of rotation, 2. The angle of rotation, 3. The direction in which the rotation is affected, and 4. The order of the rotational symmetry. Line symmetry and rotational symmetry. You have been observing many shapes and their symmetries so far. By now, you would have understood that some shapes have only line symmetry, some have only rotational symmetry, and some have both line symmetry and rotational symmetry. For example, consider the square shape. How many lines of symmetry does it have? Does it have any rotational symmetry? If yes, what is the order of the rotational symmetry? Yes, it has a rotational symmetry of order 4. The circle is the most perfect symmetrical figure because it can be rotated around its center through any angle, and at the same time it has unlimited number of lines of symmetry. Observe any circle pattern. Every line through the center, that is every diameter, forms a line of reflectional symmetry, and it has rotational symmetry around the center for every angle. Class 7